no idea where that comes from. The next term is 9. This is 5. I don't actually know this one. Okay, let's go back. I don't really care for statistics, so I'm going to skip most of the statistics ones. Integral functions, this might be fun. Two different integral functions, f1 and f2, are assigned to the function f. Show that the functions f1 and f2 have no common points. This is a really good question. Let's see if anyone answered it. Let's say f is, I'm sorry, I need a derivative. Okay, all right, let's make a video. Oh no, go back, go back. Okay. Hmm. All right. What is today? Here we go. Sorry, y'all, my computer is running very slow. Okay, here we go. All right, so I forget where we pulled this one from. Let's look and see. We got this one from the Homework Help subreddit from user itbok. Itbk, I don't know. Itbk? Who knows? And this is a good question. This is really interesting to understand that integrals give you families of functions. And so this is that infamous plus c that we see when we integrate something. So this is two different integral functions, f1, big F1, that's the first thing, big F1, okay, and big F2 are assigned to the function f. This is probably not super not a super good way to state this, and I think that is probably in large part where the confusion is coming. So let's say these are functions in x. Why not? So basically what we're trying to say is here, the derivative of this big F function, right, which is, it's an integral of something. So the derivative of this is equal to f. That's this function f, which is also equal to the derivative with respect to x, let's say, of big F. Okay, and maybe I'm being a little, I don't know, actually I think this notation's fine. So that's the relationship here. These two functions, big F1 and big F2, have the same derivative. So if we take the integral of f, all right, take the integral of f, then this is going to equal big F plus c, okay? And then big F plus c1, okay? This will equal big F1, all right? And then big F2 is going to be big F plus a different constant, okay? Now we've seen this when we look at the actual integral of a function. We'll get something like this. The function's exactly the same slope-wise everywhere, but it's just offset by some constant. That's what we're working with here. So what do we have to prove? It says I have to find f and its integral functions f1 and f2. Okay, so that's basically it. This is how you would show it. You find these two things. You show the integral. Now, basically, you want to show that they have no common points. Okay, so suppose, how would we start this? We want to assume that that they are not equal. So assume f1 is not equal to f2. Okay. Then you could say that f1 of x is equal to f of x plus c, 1, and f2 of x is equal to f of x plus c2. And you should put that in there somewhere with some justification. What's the justification for this? Antiderivative theorem, is that the name of it? I don't know. I just studied this recently. I should know this. But essentially that's it. You take the integral of f, and it's big F. We don't know what the integral function is, but it's we assume that we can take the integral of it since they said it's integrable. And you get big F, right, plus c. Now, if f1 is not equal to f2, then there's some differing constant here, okay? Where c1 is not equal to c2, okay? So you can show that f1 of, let's say, a is equal to f of a plus c1 and f2 of a is equal to f of a plus c2. And then we would say that f of a plus c1 is not equal to f of a plus c2. And there you have it. And this isn't super rigorous, but I think it should help you get where you're going. Dun, 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 dun. Where do I even start? How do I even integrate? Yeah, so that big F is that notation. How do I even integrate, right? You can't integrate because you want to assume as little as possible about this function. You're assuming that it is a function that is integrable. Okay, well, so how do I represent the integral of this f? Well, the integral of f is big F. And maybe that's like, sounds kind of cheaty, but if you had been doing these problems, you would have seen this before. This kind of like referencing the integral of a function as the uppercase letter, and then you'd have no problem. That's just a notation thing. You didn't know how to write it down. If you don't know how to express these things and you get them in homework, write a lot of words and leave it alone. Go just do your homework before it's due, right? Leave your work there and go away from it. Come back to it later, and then you can look and see your argument, see the holes in your argument, rephrase things so they sound better to you, and eventually I think if you let your mind work on a problem, it becomes a lot easier. Doing these kind of proofy problems all in one shot is too difficult. Yeah, I think this is fine. I think the post that the user was in 11th grade, and usually those kind of classes are like more lax and less good. So that's probably why you're having problems with proofs. This is a cool problem though. Okay, there it is. I should leave a time hack. When I finish this. All right. may just end up working out my own problems here. Homework help. Let's go by math. Oh, I see. I popped it up, closed the pop. All right. Year 13 math. Oof. No. Geometry, maybe. Let's try geometry. Man, I make all sorts of dumb faces. I have the chat on my phone, so if you come in the chat room, hit us up in the chat, say hello. Also, click that link to my Patreon. What does this say? Yeah, but the thing got froze when I'm making a really stupid face. This is like a huge insecurity of mine that I'm going to make dumb faces on here. Okay, prove the following using either a two-column proof of a flowchart. I think they mean or a flowchart. Make sure to include all of your reasons to support your statements. Okay, so we are given that side TR is congruent to RE, and angle TRK is congruent to ERK. Okay, so we want to prove that RTK is congruent to RTK. All right, this is, and they gave you some for the next problem. Okay, let me get a little picture of this, and we'll work on this one. Is it number 1 or number 2? I guess I'll snap both of these. Just in case, you know. All right. Hopefully this will be better than the last one. Okay, we will add an image, and here it is. All right, this is kind of small, so I will make it here. There it is. Okay, prove the following using either a two-column proof or a flowchart. I'm going to do two-column proofs congruent to triangle ERK. Triangle ERK. Oh, looks so my internet connection is really bad, and I think it's worsened by this coronavirus having everyone at home. So if this gets cut off and there's some question, hopefully my work on the paper will be sufficient. But please send me a message if it's cut off and you don't understand. I'll update it. Okay. So TRK is congruent to ERK. These are the triangles now, and this is the side angle side theorem. All right. If you don't see that, here's a side, here's an angle, here's a side, here's a side, here's an angle, here's the same side. That's pretty cool. How are you supposed to know this? Many of you have memorized these things, and that's why you struggle. It's really, really, really important that you build these things up from first principles. That's the only way you're ever going to understand it. Start from the assumptions and the definitions and work your way up to these bigger theorems, okay? Read the textbook. It's way better than anything you're getting in class or on YouTube. It's definitely better than, show me an example on one of these Pearson products or something, all right? Okay, so now that we have two congruent triangles, corresponding angles of congruent triangles are congruent. So let's see, RTK is congruent to REK. All right, so angle RTK is congruent to angle REK. So let's say corresponding, this might be a named theorem, I forget its name, angles in congruent triangles are congruent. Yeah. So the major problems that you're going to have with these proofs are you don't know the theorems, right? And you don't know them because you memorized them or tried to. You don't know the notation, which is something that you need to go back and you need to read your textbook. And actually learning how to read a textbook is a big important thing. If people want to post comments or questions about that, I can help with that. And maybe you just don't know the assumptions and the definitions. So the last thing is maybe like you have no experience with proofs. Geometry is everyone's first experience with proofs, and they can be kind of tough the first time around. But really, you're just arguing here. Okay, they give you something, and then you are supposed to argue to show that whatever thing here, the proof statement, the angle RTK is congruent to angle REK. You're making an argument that that's true based on what you're given. So there's nothing fancy about it. Oh, a bunch of people just popped in at once. Hey, welcome. Say hello in the group chat, please. I'm going to do the second part of this question now. If you're just joining us coming from the first question, I apologize. It's not very good, but I think it's enough to get you there, so hopefully it'll help. All right, and if I rant in the middle of these, feel free to hurry me along. Okay, complete the two-column proof below. So given HT is perpendicular to AO. So this is A over here. It looks like I cut it off, or maybe it's just slid over there. So this is perpendicular here. Angle HAT is congruent to okay. So this is the justification, angle sides. I hate these two-column proofs. So the reason why you're using angle side shows congruency is because you want to show two triangles are congruent, right? So here we can call this triangle AHT. AHT is congruent to triangle OHT. Okay. So if these two triangles are congruent, that means this is congruent to this. Okay. Corresponding sides of congruent triangles are congruent. That's probably a theorem that's named. I don't know it. Okay. All right. So we finished this one. Let's refresh this. Oh man, this coronavirus thing is really killing me. Like every single day, my internet is so slow. I just don't know how I'm supposed to make videos. And I tutor online too. A huge portion of my income comes from online tutoring, and you just can't get a good connection. I suppose that's a good sign for humanity, though. At least everyone's staying home and we're not getting each other sick. All right, bummer. No new questions. Let's see what else there may be on here. I need to find the altitudes of these two triangles, and what's shown is all of the given information. Okay, geometry is fun. I could use some geometry questions. Okay. Woof. Let's see what they mean by altitude. Definition, altitude. Wikipedia. Let's put triangle in here as well. Okay, so I don't through the vertex. Okay. All right. This is kind of I don't know if I like that. Triangle altitude definition. See, this is more along my lines of, or more along the lines of my understanding of altitude. This definition here. Let's see what Wikipedia says. I feel like Wikipedia is the most trustworthy definition source. Okay, in geometry, an altitude of a triangle is a line segment through a vertex. Okay, so that's the thing about this is, I want you guys, when you post questions, give us all the, this is nice because it's super zoomed in, but give us all of the instructions, because this is not clear to me that you're doing the right thing. The non-trivial altitude of a right triangle divides the triangle into two smaller right triangles. Sure. Okay, so maybe that user is the most correct, that they want the non-trivial altitude. These are altitudes here. Because this is a right angle, this would be another altitude here. All right, let's do this. Let's find the non-trivial altitudes. I like what that other user said. Who is that? Kempf. Thanks, Kempf. Okay. So we go to Sketchbook. And let's add this. This is the one, that's it. And let's let this user know we're working on their homework in a live stream. Y'all, if you come here, please subscribe. Please subscribe. I don't know how long I'm going to keep doing these videos. Hopefully, you know, forever, but I'd like to do it more, especially now that I'm like trapped in, so we're all trapped together now. Okay, so we want to find the altitudes, and that other user made a really nice point that we want the non-trivial altitudes. Although, maybe let's find this one too, since why not? Okay, so an altitude is the one that goes through a vertex of a triangle and makes a perpendicular angle with the opposite side. So let's see if we can, there we go. That's an altitude, okay? So we need to figure out this length here. What can we do? What can we do? So we can use our trig relationships. All right, let's call this angle theta here. This angle is theta. Okay, so if we look across, if we look opposite of this, we have 3, and then adjacent to it, we have 3 root 3. Okay, actually, let's figure out this long side here. Oh, we don't need that. Okay, so opposite and adjacent, right? So what trig function do we know that has the opposite and the adjacent in it? Okay, we know that the tangent of theta is equal to the opposite over the adjacent, right? That's by definition. If you need help remembering that, we've got SOHCAHTOA. Okay. Now, in this case, the opposite is 3, and then the adjacent is root 3, or 3 root 3. Okay, so these guys cancel. This is 1 over root 3. And so we would put that into our calculator, figure out what this angle is. Actually, let's do it. I don't think that's on the unit circle. Would it be? So this would be 1/2 divided by root 3. No. Yeah. That is, okay, let me just put it in. Okay, so we're going to do second 10 of 1 over root 3. Yeah, okay. So this is on the unit circle. This is going to be equal to 30 degrees. This is 60 degrees then. And we can figure out everything from here. So this triangle is now a 30-60 angle as well, except for we want to figure out so now we have to look at the inset triangle. So this is, let's call this A, B, C. So we're looking at triangle ABC before we had triangle ADC. Now with this one, this 30 degrees is here, but we have a new right angle. That's angle B, okay? So we can take let's see, we know this is now the hypotenuse of ABC. You gotta see that, it's opposite to 90. Okay, this is now our hypotenuse, and we need this side, which is opposite to angle theta. All right, so what trig function uses the opposite in the hypotenuse? Well, that is the sine of theta. The sine of theta is equal to the opposite, which in this case is x. I just set it to be x, it doesn't matter, you could put any variable you want, divided by the hypotenuse, which is 3 root 3. Okay. Now we actually know theta because we figured out in the last part. So this is sine of 30. Okay. Now we can solve for x. We multiply both sides by 3 root 3, and then we get x equals 3 root 3 sine of 30. And so this we can plug into our calculators. Sine of 30 is 1/2. So this is 3 root 3 times 1/2, which equals 2. Sine of 30 is 1/2. Okay. All right, so that is the altitude, the non-trivial altitude, as that Kempf Reddit user said. Thank you for that observation, because I was about to do a bunch of stuff that wasn't necessary. And let's do the same thing for the other one. Okay, first thing to notice is this is an altitude and this is an altitude. So maybe let's do this one since it's not done for us. And for this, we have a right angle here, so we can use the Pythagorean theorem. Let's call this y. We already used x. So we'll say 6 squared plus y squared equals 6 root 2 squared. Okay, this is the Pythagorean theorem. We know a squared plus b squared equals c squared. When can we use this? Whenever there is a right angle between these guys. Well, there's a right angle between these guys, so we can use it. Okay. We love Pythagoras. He gives us all kinds of good stuff. So let's solve here. We'll subtract 6 squared from both sides. We get y squared equals, actually maybe, let's simplify this real quick. This is 6 times 6, which is 36, and root 2 times root 2, which is 2. So we get 6 squared times 2. That's what that is, okay? Minus this guy. We subtracted 6 squared from both sides. 6 squared, okay. Now, y squared equals 6 squared times 2 minus 1. I factored out a 6 squared. Why did I do that? Just because it would make things easier. So y squared equals 6 squared. 2 minus 1 is 1, so times 1, but we don't really need to write that. We can just leave it like this. Now we can clearly see y is plus or minus 6. We're going to take the positive because we're not in the Cartesian plane. We're just on the plane here, so we're going to make this positive 6. Take the positive because it's the length of a triangle, and triangles can't have, or sides can't have negative lengths. Lengths can't be negative. We'll amend that when we start doing more analytic kinds of geometry with coordinate planes and things like that. But for now, just take the positive. And here we have it. Y equals 6. So then we'll do the other one. Boom, 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 boom. Okay, we drop an altitude. We go from a vertex to the opposite side, and we make a perpendicular line, or a perpendicular angle. That's the definition of an altitude that we just looked up. All right, so then let's figure out this angle. Let's call this angle theta, okay? And we can make, oh, maybe I should write this down. This is, what did I figure this one was? 6 also? Yeah, 72. Okay, that makes sense. All right, so we know that these guys have equal sides or equal legs, and the only way that happens is this is 45 degrees, or pi over 4. This has to be equal to this because the legs are equal here and here. So we have a 45, 45, 90 right triangle, and we can use that to our advantage. Okay, so now the hypotenuse is 6, and this side from here to here is half of this full thing, because this is an angled bisector, okay? So half of 6 root 2 is 3 root 2. And so now we have an adjacent and we have a hypotenuse. Okay, what trig relationship uses the adjacent and the hypotenuse? So that is going to be the cosine. The cosine of theta equals the adjacent over the hypotenuse, right? And so we're looking for, oh, actually, I'm sorry. What do we want? We don't want that. We want the opposite. We know the adjacent. We want the opposite. So we can either use tangent with these two, or we can use sine. So let's use sine. We need to figure out this. Let's call this side z. So the sine of theta equals z over 6. Okay, opposite over hypotenuse. But we know that theta is equal to 45. So this is the sine of pi over 4 is equal to z over 6, okay? And then we'll solve for z, we'll multiply both sides by 6. So z equals 6 sine of pi over 4. Now, you can go to your calculator or your unit circle, and this is 45 degrees, keep that in mind. And you can look this up. So then 6, the sine of pi over 4 is root 2 over 2, okay? And then we can just simplify. There's a factor of 2 here, and a factor of 2 here. So this becomes 3 root 2. And that makes sense also because this is another 45, 45, 90 right triangle. Yeah, super interesting. Triangles are fun. We love triangles. Hopefully that helped and wasn't too long. Let's see if anybody posted some new stuff. If I don't see any other good questions, I will probably start doing my own problems. I'm studying calculus again. Word stories to qualitative graphs. Easily tell the difference between 1 and 2. I'm not really sure what's going on here. Oh, is this like whether or not you can factor it? Or have they completed the square? Oh, is that what they did? They completed the square. Yes, this is completing the square. How can you easily tell the difference between 1 and 2? Okay. Yeah, I don't think I'm going to answer this question. Let's do some calculus. Well, I don't know. I should do, oh, I closed it. Dang. Let's try cheat at math. That's sometimes good. Stats, finding z-value. There's no equality here. The integral of f of x sine x dx minus f of x cosine x. Yeah. Yeah. This looks like integration by parts. Let me look at it in this formulation. What are we trying to do? So we can do this integration. I really don't want to do this problem. Oh, integral function solution. Yeah. I'm going to type this out while I say it. It was near the beginning. Oops. Video post after finish. All right. Oops. Yeah. This could be fun. You enter a bookstore to get books to read during confinement. You like poetry and comics. The bookseller recommends 9 poetry books and 11 comics. You decide to buy 5 of them from the bookseller's recommendations. How many different ways can you choose your purchases? So okay, this could be good. if you want to buy 2 poetry books and 3 comic books, how many different ways can you? Okay. These are like combinatorics questions. 5 books. See, I don't feel confident that I can answer this one. I think you would just do 9 choose 2 plus 11 choose 3. But I'm not positive about that, so I actually don't think I'll answer this one. Area enclosed by the curves. Let me draw these and explain if you can. Oh, actually, let me just see if this is a stupid z-value question. Metus 25 standard deviation is 800. Okay. Something's wrong here. This must be x bar. No, this is the mean. Yeah. So I don't know what this upper bound is, you know. So guys, if you're posting questions, like take a picture of it. That's the best way. Oh, this is solved. Okay. All right. Well, I'm gonna do some calculus. You guys can watch me do math if there's anybody. Okay, you're welcome. Thank you for posting in the chat if you're still listening. Okay. All right. Yeah, it's popping in the group chat, everybody. Ooh, I got new online tutoring opportunities. Whoa. Whoa. All right, what's that? I'm going to do my own math. I guess I'll talk just in case someone comes in, but I don't know what I should say. So I started working on this problem, but I didn't actually finish. So we're going to use substitution to evaluate the definite integral. Okay, so let me copy this guy down. And everybody, this is a great book. It's open source and it's free, and it's written by MIT's infamous Gil Strang and some colleague of his who I'm not familiar with. But that doesn't mean that they're not also dope. But I highly, highly, highly recommend this textbook, both for students who already have a textbook and for professors who do not have a textbook already, or even if you already do, just use the better textbook. This one is better than what you have. I feel pretty confident in saying that, and it's also free. Okay, this is what we're doing. So I noticed that this is a constant multiple of the derivative of this guy. So I'm going to use the substitution. I'm going to do use substitution. So I'm going to say let 2y squared equal u. Then this implies that 1/4 du equals y dy. Okay. So I could have just implicitly derived both sides and then solved for du. I just did it in one thing. And I knew I needed to get that because I see a y and a dy here. All right, so then I've got y dy. So I have all of the factors. So I can totally substitute. Now, since this is in terms of y, that means that these are in terms of y. I'm doing a change of variable, so I need to figure out what those are in terms of u. So I can just leave it all in one thing instead of going back at the end. So what I'm going to do is when y equals -1, u equals 2 times -1 squared, which equals 2. And y equals 0 implies that u equals 0. Okay, so we're going to go from 2 to 0. All right. So here we have from 2 to 0. And I'm going to do the substitution from this portion here. And I'm going to say, oh, actually, I made a mistake. This should be 2y minus 3 equal to u. All right, so now we're better. Okay, so this is going to be, so for this portion, this will become u, and then this and this will become du. All right, so I will get u to the 5th du. Now I just have to integrate this. This is a lot easier. So this is going to be equal to u to the 6th divided by 6, evaluated from 2 to 0. All right, so this will be 0 minus 2 to the 6th divided by 6, which equals -2 to the 5th over 3. And that is 8 times 4, which is 32 over 3. Okay, let's see if I got it right. So this is generally my process. I used to involve Chegg heavily with this process because I do the evens and the odds when I'm studying. Oh, I made a mistake. 91 over 3. 5.29, that is what I'm doing. But you know, I didn't want to pay for Chegg anymore. I don't like that. I don't like Chegg. I think that knowledge is free. You just have to know where to look, or put a little hard work into it. All right, where are we at here? So I must have made a mistake somewhere, or unless I have an equivalent answer and just didn't notice it. What did it say? 91 out of 3. Now, it is true that occasionally, oh, I know why. My bounds of integration are wrong. Okay, so this is good. I'm glad that I made this mistake because this is really easy to make. So what happened is when I figured out this 0 and this 2, I did that based off of what I originally had figured out. You see my work here. So what we want to do is we want to redo this and get our bounds of integration. So when y equals -1, u equals 2 times -1 squared minus 3, which is equal to 2 minus 3, which is -1. Okay, and then when y equals 0, this implies that u equals 2 times 0 minus 3, which equals -3. So this integration, actually, I did wrong, should go from -3, oh wait. It should go from -1 to -3. And so it went from -1 to 0, so -1, yes, okay. So then this will become -1 and -3. Okay. That's what I did wrong. Which is why I practice. All right. So then we are going to do -3 to the 6th, which is an even number. So this is going to be 3 to the 6th divided by 6. And then this is going to be minus -1 to the 6th, which is also going to be positive. So we'll get 1 over 6. And then this is going to be, let's do this. So this is 27 times 27, which is 729. So 728 over 6. And I think we can get a 2 out of here. Hopefully I didn't mess it up again. So this will be 3, 4. Oops, no, we're dividing by 2. 3, 6, 4 over 3. And then this is 7, 13. So that should be fine, but still not right. Still not right. Let's see what else. Bum, bum, bum. 91. We are expecting 91. Okay. 2y squared. 2y squared. This becomes 1 times 2 minus 3 is negative 1. Oh! Sorry, I'm getting off the ground slow today. This is 1/4. I forgot my factor of 1/4. So this gives us a 1/4, and then we've got a 1/4 here, and then we've got a 1/4 here, and a 1/4 here. All right, let's see what this is. This divisible by 4. We've got 91. Okay. So this becomes 91 over 3, which is what we wanted. So go slow, be careful. That is the take home from this. And practice. Lots of practice. Let's see how much time I have until my next session. My students dropped off considerably since the coronavirus pandemic hit. So I have a lot more free time. All right. We got some time. Set an alarm for 5:45. All right. It's my personal assistant. Okay, so example 5.35. So when I get to examples, I actually try to work them before I look at the solution. So let's work this guy. So we're going to use substitution with an exponential function. All right, it's been a long time since I've done these like integral type problems. And I'm trying to study for the subject exam, GRE. Really, I just like didn't work very hard when I actually did my undergrad, so I'm trying to, in general, become better at math. All right, so use substitution. That's what we're doing with this exponential function. So we've got, so here I see that if I say let the exponent of this guy here, 4x squared plus 3 equal u, okay, then du equals 8x, and so x equals 1/8 du. Actually, I should say this is, if I'm being really careful, this is 8x dx, and then 1/8 du equals x dx. Okay, so this is important, and I don't want to forget that like I did on the last round. Now this is a definite integral, so we have bounds here. So x equal to 0 implies that u equals 4 times 0 squared plus 3, which is equal to 3. And then x equal to 1 implies that u equals 4 times 1 squared plus 3, which is equal to 7. So we're going to go from 3 to 7 when we do this in terms of u. Okay, let's make the substitution. So we're going to go change our bounds here real quick from 3 to 7 of e to the u du. Now, what did I forget last time? 1/8. Okay. All right, so this one's super easy to integrate. We just get 1/8 times e to the u. We're going to evaluate that from 3 to 7. So that's a really fancy reason why you would use the substitution. So this isn't going to look nice in a closed form thing. This is going to be e to the 7th minus e to the 3rd. Let's see if I got it right. This is like Christmas. Yeah, okay, so they approximated it as well, but you can see that I got it right. Okay, fun. Use substitution to evaluate from 0 to 1. The integral from 0 to 1 of x squared cosine of pi halves x cubed. Okay, so we were looking for like a composition of functions. I can see here. Let's do it in the thing. This book is really great. I actually didn't realize, but you can like put little bookmarks and notes and things, like highlight and put notes in here, which is super, super cool. You know, this is like your own little digital textbook, but it's constantly being edited. I've submitted a bunch of errors from this, and you know, other people do the same. So this book just gets better and better and better. It's in the public domain, so we're making derivative works off of this right now, which is really cool. And I got to remember to go toggle my settings afterwards so that this video is open source. All right, let's get rid of this. We will insert. Okay, this is what we're working on. Normally I do this in these like notebooks. These are great. I love these. I filled up 2 of them with calculus so far. They're kind of expensive, but I don't know. I like to use them. I found a great deal on these at Costco a while ago, and I bought a pack of them, but they're about to run out. All right, so we're going to use substitution on this one. That's what directions tell us to do. I know that the derivative of this is going to be a constant multiple of that. So let's use it. So we're going to say let u equal pi halves x cubed. Okay, so this implies that du equals 3 pi over 2 times x squared dx. Okay, now from here we can divide both sides by this 3 pi over 2, and we will get pi over, oops, 2 over 3 pi du equals x squared dx. And so here we have x squared, here we have dx, and here we have our substitution for u. So we can just change this. Actually, let's figure out our bounds of integration. So x equals 1 implies, we're going to use this here, that u equals pi over 2. And then x equals 0 implies that u equals 0. Okay? And here we go. And I got these just by substituting x in here and here. Okay? Nothing fancy if you didn't follow it. It's just, for some reason when I first learned this, that was really hard for me. Okay, so I'm not going to forget the constant multiple, and I'm just going to bring it outside the integral. It reads a little better that way. And so then we make our substitution. So we have cosine of u, and then du. Now here's that 2 over 3 pi from here, and this is substituting in for x squared and dx. That's the whole point, right? This is du. All right, what's the integral of cosine? That's negative sine. Oh, no, that's sine. So this is going to be 2 over 3 pi times sine of u, evaluated from 0 to pi over 2. So this becomes 2 over 3 pi, and then we get sine pi over 2 minus sine of 0, and this is equal to 2 over 3 pi, and the sine of pi over 2 is 1, and the sine of 0 is 0, and so this equals 2 over 3 pi. Let's see, did I get it right? This is checkpoint 30, 2 over 3 pi. All right, beautiful. And they give us an approximation, which we'll ignore. Okay, substitution may be only one of the techniques needed to evaluate a definite integral. All of the properties and rules of integration apply independently, and trigonometric functions may need to be rewritten using a trigonometric identity before we can apply substitution. Okay, also we have the option of replacing the original expression for u after we find the antiderivative. Okay, which means that we do not have to change the limits of integration. So this is how I always did it. And then, maybe I just didn't learn how to change the limits, and that really, really confused me. And then when I went to so I took Calc 1 and 2 at a community college in Nebraska, and then when I went to university, like a decade plus later, my teacher did where they actually changed the bounds, and I was really confused. So it's good that I am going back to look over this stuff again. But this is, okay, I don't understand why that whole talk was about not changing the thing. All right, so we're going to integrate this. I guess I should be looking at the chat room from time to time. Oh, yeah. Okay, I'm sorry that I missed your question. Hopefully you haven't been waiting long. The curve y equals f of x is in the range of 0 to 1. And f of x is greater than 0, okay? It rotates about the x-axis and forms the volume of each from 0 to x. Okay. 0 less than x, which is less than 1. Okay. Oh, okay. I'm sorry, this is tough. All right. Amino. All right, so let me see. So this is what we just did. Okay. Why is this not? Oh, that's bizarre. Okay. So what do we have here? So this says that, so we're given a curve, y equals f of x. And when x is in the interval from 0 to 1, f of x f of x is positive. Is that what it says? F of x is positive. Okay. Or I should say non-negative. And it rotates about the x-axis. So here we go. Here's a curve, non-negative from 0 to 1. And then it's going to rotate about here. Okay. Sorry, that's a terrible shape. It should look roughly like a vase or something. So those circles, the discs should be down lower. Yeah, if there's some question, I'm glad that you asked something in the chat. Like, definitely if my explanation doesn't make sense, please post something as soon as you're like, yeah, I'm confused. Okay, so this is the volume that we're getting, and then so x is between 0 and, okay, so I'm having a little bit of a hard time understanding the last part of this. Informs the volume of each volume 0 to x, where x is between 0 and 1, is x to the 5th. Okay, so we need to find the function. So the integral of this function from 0 to x, let's actually use a dummy variable. So we'll say f of s ds. Okay, cool. So this is going to be big F of x plus c. Actually, we'll say from 0 to 1, let's make it a definite, is equal to x to the 5th. So what is the original function? I guess x to the 4th? 5x to the 4th? Plus some constant. So if we took the derivative of this, we would get that. No, not the constant. The constant should go with the integral. So let's just, instead of doing, so we'll say that the integral function is equal to x to the 5th plus c. And since it's a definite interval, this will go away. But the derivative should give us that. So I think this is, oh, okay. The volume is given by x to the 5th. The volume is given by x to the 5th. So we would take a disk here. The radius of each of these things would be, so the radius of this is pi r square, or the area of each slice. This is like a sum from 0 to x over this thing, over each of these slices. So each one of these slices, we take a slice, take a slice, we take a slice, all the way down from 0 to x, and we add those together. That's what the integral for the volume gives us. So we can say the integral from 0 to x of pi pi r squared. R is going to be given by f of x. So we'll say f of x squared dx equals x to the fifth. So let's try and integrate. Let's say, I think that maybe we could call this let's try the integral, and we're going to say f of x equals x squared over pi over root pi. So this makes pi times x squared over root pi squared dx, and we can simplify this, and it will be the integral, say, root 5 of 5x to the fourth dx. The integral of this would be equal to x to the fifth. Okay. Sorry, this is kind of a tough problem. I haven't done these in a while. I think that's right, though. So basically what you need to figure out is that we're taking a sum from here to here of all these infinitely many thin slices of this shape, okay, where the radius of each circle is given by f of x. So I know that the area of each of those slices is given this. So I'm going to integrate over the areas of each of the slices. Now, r is given by f of x. It's the height of the graph here at any point x, okay? And so this is the integral that I need to set equal to x to the fifth. Now, I had to figure out how to cancel this with something here. I needed something to cancel there. And then, so that had to give me the root 2, since I know I'm going to square this. Then I needed the ultimate x to be x to the fourth, the final thing. I needed this to be x to the fourth, because going up 1 degree in the exponent gives us x to the fifth. So x squared squared would give me that, so I knew I had to have an x squared in there. And then I knew I needed a 5x to the fourth here. So the square root of 5 squared would give me the 5, and that's where I got that from. Then you see once we square this, the pi's cancel out, and I'm just left with this 5x to the fourth, and the integral of that is x to the fifth, which is said to give the volume. So that is a very long-winded explanation. I'm really sorry that wasn't very concise and easy. Hopefully it helped. Let me know if you are okay with that in the chat, Amino. This is crazy. It's like a private tutoring session for Amino in the group chat. Tell your friends to post questions. Everyone is stuck at home right now, so if you come across this and you don't have a teacher and I'm doing better than nothing or better than whoever you have available, come post questions, okay? Subscribe, comment, do all those things. It helps me out. I don't know where we're going with this, but you know, maybe one day I'll be able to be a YouTube math tutor. That'll be my dream job. All right. Let me know where you're at with that, Amino, if you're still in. Hopefully I didn't run you off. All right, so let's go back to our thing. Did I do this one? I did not do this one. Okay, good. All right, well, I'm glad that helped you. If you have any more questions, please post them and share the channel with your friends. They can send me a message, or I have a subreddit. Look through my Reddit post history, and you'll see that I have a subreddit that I just made a few days ago, or maybe it's just a few weeks ago at this point, where you can post questions directly to me, and I'll try to get to them as soon as I can. So I'm glad it helped you. Don't struggle. Just come post questions. We'll help you. All right, where are we at? Got like 40 minutes left until I got to jump off this session. So hit me with your best questions. Yeah, post another question. If you don't post questions, I'm just going to do calculus. So post them away. I really do appreciate the questions, by the way. Here, let me get this out of here. We'll just do yours. I've got like 40 minutes until I got to jump off this this session, but yeah, post all your questions. I'm gonna wait while you're typing this. I'm gonna get some water. I thought maybe it would be good to like do a Zoom session. I don't know if you have Zoom. It's like a conference call thing, and just like live stream a Zoom question and answer. You are the most interactive person I've had so far. So if you are curious about doing something like that, where we like conference call and you can ask me your questions directly, you'd be on the internet with me. You'd be on YouTube Live. So consider that. But yeah, let's do a live question and answer. I think people would enjoy watching that, maybe. Sorry, I'm getting a little misty. My friend's having a really bad time at work. Okay. Oh, ellipses. I just looked through ellipses again recently. Conic sections are interesting. Okay. So the question from Amino is the ellipse 4x squared plus 36y squared equals 9 rotates about the y-axis. Okay, so let's draw this. Here we go. We have an ellipse. Oh goodness. Actually, I can. You know what? I've got this really fancy ellipse tool. Here's an ellipse. Look at us. I'm gonna shrink you down. I don't know what exactly. I'm not gonna draw this perfectly, but here's an ellipse. We're gonna rotate that around. So we are going to get like a donut-shaped thing, okay, without the hole in it. It's like a flying saucer shape, which is really cool. Okay, cool. All right, now That's our equation. Rotates, calculate the volume of the resulting piece. So how would we do this? Rotates about the y-axis. So I guess we could integrate over y. What would be the easiest? I think maybe... so Amina, are you comfortable with polar coordinates? Have you learned about polar coordinates? I'm just gonna, I'll wait for you to type it in the group chat. Polar coordinates. I don't know if this is actually going to be easier, but I think it might be. No, maybe I should just stick with this. Yeah, I'll just stick with this. Okay, so I'm gonna integrate over y, I think. The radius. So we have some choices here. We gotta decide how we're gonna do our slices. If we rotate this around the y-axis, we could choose our slices in this direction, right? Okay. You did talk about it in class though? That's the one where points are graphed by r theta instead of xy. Right, so xy is what we're working with here. And then r theta is like, this is length r, and then this is angle theta. And then I guess you would have phi as well, which is your angle between here and here. So, but that's maybe not super important. I think I should probably stick to Cartesian coordinates. Okay. I'm gonna do all this. All right. So how do we want to slice this up? What is our vertices? So I'm going to go to the Purple Math website. So Purple Math conic sections, or let's actually do ellipses. And this is a good website. It's got really good notes on all of these topics. Sorry, my internet is so slow right now. Okay, so what gives us our foci? All right. So we're going to divide both of these by 36. And then we will get x squared over 9 plus y squared over, no, we're going to divide them both by 9. So this will be 4 over 9 plus 4 equals 1. Okay, so we divided through by 9, so this is x squared over 9/4 plus y squared over 1/4 equal to 1. Okay, so that gives us our a squared and b squared. It's centered about the origin, and then so that gives us the major, so this is one vertex, and that's the other vertex. Okay, so that means that this is 0, and this is 9/4. Or I should say it's the square root of 9/4, which is 3/2. Okay, that's 3/2. And so this is negative 3/2. And then this is 1/2, and this is negative 1/2. All right, that comes from this formula here. Hopefully that helps. Okay, so what do we want to do? We can integrate from See, the issue with doing it in Cartesian coordinates is that the radius, or this ellipse, changes like each time you make a slice. Let's look up the area of an ellipse formula. I gotta get good at these problems anyway. I think I'm about to. I'm studying chapter 5 of that textbook, and I don't want the solver, I just want the formula. Oh, here it is. Oh, that's really easy, pi AB. However, this will change as we get to as we go. Yeah, A and B change as you go up this thing. So, all right, let's look at just one slice of this thing. So as we go from 0 to 3/2, if x is 3/2, then that gives us A. B would be all right, so I just want to stop and only think about this thing. So we're gonna integrate from 0 to 3/2, and then we're integrating the area of each slice. I need to multiply this by 2 gives me this whole thing. Oh, I think I'm making too much, I'm making this too difficult. So it's rotating around the y-axis, so we still have disks. We have perfect disks. So how can we, so the area is going to be pi times r squared, where the radius is going to be given by x. And so we can just solve for x. Okay, great. Here we go. So we're going to do pi r squared, and the radius is like from here to here. So let's solve for x. So I'm going to do x squared equals 9 minus 36y squared over 4, and then x equals plus or minus the square root of 9 minus 36y squared over 4, which is equal to plus or minus square root of 9 minus 36y squared over 2. Okay. And we are going to go from 0 to 3/2, and then here the radius is x. Oh, do we need to solve it? Okay, so we're going to go from 0 to 1/2, and since I put everything in terms of y, then our radius is equal to x squared, so we can actually just take this. So we're going to take pi times 9 minus 36 y squared over 4 dy. So we're going to integrate over y. All right. So we can bring, let's say, pi fourths. Actually, squared dy, and sorry, I normally am able to scroll down when I use a different thing. Oh, you know what I can do? Okay. All right, so then this is going to be pi over 4, and we're still only working in that first quadrant, that volume in the first quadrant. So we're going to have to multiply this by 1, 2, 3, 4 in order to get the actual volume. Or let me double check that. From 0 to 1/2. So this is the top hemisphere. So we're going to have to do this by 2. Okay. All right, so this is going to be 9y minus 12y cubed evaluated from 0 to 1/2. Okay, and let's go ahead and I'm going to multiply this by 2 now. So this is going to be, so just so I don't forget, comes up here. This is pi over 2 times 9 times 1/2 minus 12 times 1/2 cubed. And this would be minus 0 of everything, but 9 times 0 minus 12 times 0 is 0, so we'll just leave that off. I'm sorry, I'm sort of like rambling now. So this is 9/2 minus, minus 12/8, and then this becomes pi over 2 times 6 minus 12 over 8, which is pi over 2. 36 minus 12 is 24, divided by 8 is 3, so this is 3 pi over 2. 3 pi over 2. Okay, so let's talk about what I did here. And actually, let me make sure that you're still with me. Okay. All right, so we have this ellipse here. Let me draw us a nice ellipse again. Boom, here's an ellipse. Okay, and then we rotate this, and I wonder if I can just do a couple of rotations here. We rotate this around the y-axis, and we get, this actually looks like I don't know if this actually looks correct. I think I should change the perspective. I'm not going to do this. Okay, we'll play with that later. Okay, so here it is. We rotate it around the y-axis this way. Okay, so what that means is you have a circular ellipsoid situation. I don't know what the proper name of it is, but the discs cut horizontally are circles. They're perfect circles. So we're going to take a sum of the areas of those circles. Now, you can choose to integrate over the x or over the y. I chose the y. I wanted to integrate over the y. So I did from 0 to 1/2. Where did I find the 0 to 1/2? Well, I went to this website here. Okay. this purple math thing, and I recommend you read this article, especially if you can find something equivalent in your native language, that would be really nice. Text your native language, and I'll see if I can find something. Okay, so I solved that equation into this format, which you can see a squared and b squared there. And when I did that, I found that a squared and b squared were 1/4 and 9/4. Okay, so I took the square root of that, and that's where I got the 3/2 and the 1/2. And so then I knew my bounds for, so here was my 1/2. Since I was integrating over y, I went from the origin to here. And I knew that I needed twice whatever that top hemisphere was. So I would account for the bottom as well. I could have integrated over -1/2 to 1/2. That would have had the same result. Okay. Then from here, I just simplified, right? I took the pi out, I took the 4 out, and then I integrated this, and I got 9y minus 12y cubed from 0 to 1/2. Then I just evaluated that, and I got 3 pi over 2. So this is a good question. The thing that made it easier for me was realizing that it was rotated around the y-axis, and then that would give us our circular disks, which is a lot easier to deal with the area of that because it only depends on the radius, and you can get the radius from your x value at that point. If we wanted to integrate over x, it would have been a lot harder. Would we have been able to use? So we would not have been able to use the area of a circle as our slices. We would have had to use the area of an ellipse, and then the area of the ellipse would change, or the a and b. So if the area for an ellipse is given by pi times a times b, where a and b are those vertices. If I had, or the distance away from, I guess we would call it the semi-axis, half of the major and minor axes, those would have changed each slice as we go down this, spaceship-shaped thing. So integrating over y is the more convenient way to do it, and that's the trick to solving it. Hopefully that helped. I'm really sorry it was ambling. Do you have another question? Finland, okay. I don't speak any European languages, so I can look around though. I'll look and see if I can find a good resource like this for you. And maybe I know someone who is comfortable with Finnish, huh? You guys speak Finnish there? Oh yeah, actually I do know someone. Okay, cool. Yeah, I'll ask around. I'll find you something. Okay, hit us with another question. What else you got? It's just me and you in here, I think. I got grumblies in my tumblies today. I wish I had things to say. I don't know. I feel like we got dead air going on here. Okay. Oh, Amino and whoever else comes along. I hope I'm saying your name right. Please, please, please like, subscribe, comment, all of those things. I'm getting lots of good stuff from you in the chat, so thank you again for that. Otherwise, I'd be very lonely here doing my own math homework, which is self-assigned. Okay, here we go. This is the line y equals 1/2 x, and the parabola y equals kx squared, bounding finite region A, okay, are defined, or it says define constant k such that the area A has an area of 3. Okay, cool. This is a nice problem. So let's see if I can do it. So we have a line y equals 1/2 x, and then a parabola y equals kx squared. All right. So I'm being lazy. Why don't I actually use my tool that I have for this? All right. So here we've got some axes. And then we've got, let's call this, here we go. So here's 1/2 x, and then we need a parabola, which is kx squared. So we don't know exactly. All right, that's a perfectly symmetric parabola. So we don't know what k is yet. We got to figure out what k is. And we want to define k such that the area between, the finite region between these two, so maybe let us make a selection here. Let's take this selection, and then we will, let's move that out of the way. Get rid of all this junk. Okay, so this is really what we need to work with here. So this region is the finite region A. That's A. Okay. And we need to figure out what that area is. So we can set the bounds of integration. Both of these should go through the origin, right? So we can say that we're going to integrate over from 0 to something, okay? And this is the other place where they're equal, this point here. That's their intersection. So we need to figure out what that point is. We need 1/2 x equal to kx squared, okay? And so we can figure out this happens when kx squared minus 1/2 x equals 0. All right. Now, we get two roots from this. We get x equal to 0, or we get kx minus 1/2 equal to 0. So, solving for k, we get, or solving for x, we get x equals 1/2, 1 over 2k. All right. So x equals 1 over 2k. So this is 1 over 2k. That's how we figure out our bounds for integration. We're going to go from here to here, and this is 1 over 2k. All right, it's the intersection. All right, now we have to figure out what are we integrating. So I'm assuming that line will be bigger as long as 1 over 2k is less than 1. So let's just do 1/2 x minus k x squared dx. And then what is this? So this is the definition of our area. What should it be equal to? This should be equal to 3. All right. Now the only thing left to do is we have to solve for k. Okay. So let's just figure out what's the integral of this. So this is going to be 1/2 x squared divided by 2, which is 1/4 x squared, and then minus k thirds x cubed. Are you comfortable with this part right here? And this is going to go from 0 to 1 over 2k. And this is equal to, so this is going to be 1/4 times 1 over 2k squared minus k thirds times 1 over 2k cubed. And then we can ignore the 0 because both of those terms have x in them, so we would just get that whole term 0, so it'd be like subtracting nothing. Okay, so this whole thing is going to be equal to 3, right? This is what we need to solve for k. All right, so let's clean this up a little bit. I think this is going to be the last one for the moment because I have a client soon. All right, so let me simplify. Actually, I'll just delete this too. So we have 1/4 1 over 2k squared minus, this is a really good question, I think. 1 over 2k cubed equals 3, and there we go. Got lots of room to work now. So let's simplify. This is 1 over 16k minus 1 over 24k squared equal to 3. And then this has, this is what, 2 to the 4th. This is 2 to the 3rd times 3. So this is 1 over 2 to the 4th times k minus 1 over 2 to the 3rd times 3 times k squared equals 3. And then, so I'm going to multiply this whole thing by 2 to the 4th times 3 times k squared. Okay. So here I will get 3k minus 2 equal to 3 times, let's call that 2 to the 4th, 3 squared, k squared. And then, so here we have a quadratic, so we can find 2k's that solve this. So we'll get 2 to the 4th is 16 times 9 is 90, 54, 144 k squared minus 3k plus 2 equal to 0. And then this we're just going to work up here. We'll just solve this. So this can become 72k squared. Oh no, that is. All right. Can we? I'm not even trying to factor this. Let's so k equals 3 plus or minus. This is the quadratic formula here. So k equals negative b plus or minus radical b squared minus 4ac all over 2a. Okay, so negative b plus or minus the square root of b squared minus 4 times 144. Oh. We have an imaginary number. I must have done something wrong. Or I should say a complex number. Send me a message on Reddit. I think I need to work on this for a second, and I'll send you a link to a video with just this solution on it, so you don't have to watch an entire live stream to get to it. But I think I made a mistake somewhere, because this gives me a non-real number since it's a negative under the radical, and so that's a problem there. But this should, I mean, I imagine this would have a real solution. Why wouldn't it? Yeah. It should have a real solution, I think. When is this due? I guess hopefully you're still there. Yeah, let me know when this is due, when you have to turn it in, and then send me a message on Reddit to that Glauxy screen name, GLAUX, and then I'll make you a video. Okay, cool. All right, I'm gonna jump off now because I gotta get ready for this appointment. But maybe I'll come back on later tonight and do some more homework. Bye. Thank you. Like, subscribe, comment.